All right, before we go on to the next example, I was going to show you what's going on here in terms of the data. Now, do you see how we made 3 cuts for the quartiles? How many numbers are in each section of our data? There are 3 numbers in this section, up from the least value to the first quartile. There are 3 numbers in this section, from the first quartile to the median. There are 3 numbers in this section, from the median to the third quartile, and there are 3 numbers in this section, from the third quartile to the greatest value. So notice, I have exactly 3 data in all 4 sections, which makes sense, right? That means 25% of the data is here, from the least value to the first quartile. 25% of the data are values that occur in this range of numbers. From the first quartile to the median, that's another 25%, right? 3 values out of the 12 total values. So 25% of the values are in this range, right? From the first quartile to the median. 3 values are from the median to the third quartile. There are 3 values in this range of numbers on the number line, from 30 to 34. And there are 3 values from 34 to 38, as you can see, which is true. So each section of your box and whisker plot is 25%, which means that just the box is what percentage of our data? Well, if this is 25% from the first quartile to the median, and this is 25% from the median to the third quartile, that represents, what I have in the box represents these 6 values in the data, right? 6 out of 12, that's 50%. 50% of the data is in the box. Whenever you're looking at these videos, it's probably good to see them over and over again and watch them as many times as it takes, and then formalize your questions. That's going to help us on this next question. How do I analyze data using a box and whisker plot? The box and whiskers plot, I guess it shows whiskers, shows the body mass index. Ooh, now we're getting exciting. Shout out to our PE department of a 6th grade class. What fraction of the students have a BMI, body mass index, of at least 22? Okay, at least 22. That means 22 or above. Well, what percentage of the data, or what fraction of the data, is from the third quartile up to the greatest value? Isn't that 1/4? It's 1 out of the 4 sections of the data. So the fraction is 1/4. Are the data more spread out below the first quartile? I should be using my highlighter. Are the data more spread out below the first quartile, here, or above the third quartile, here? Explain. Okay, well, which one's more spread out? This section below the first quartile, or this section above the third quartile? Well, hopefully you can see which one's longer. The longer one is the above the third quartile. I probably should have said the data are more spread out above the third quartile, but then you'd have to watch me write it, and I'd do badly. Third quartile. Because the whisker, we're talking about the whiskers here, is longer. And I probably wasn't clear enough about that, but these are the whiskers. The whiskers are the areas from the third quartile up to the greatest value, and from the least value, and I don't have enough space, up to the first quartile. These are the whiskers. And so you can see this one on above the third quartile is definitely longer. Okay, now it says, sorry, it's changing over to, there it goes. Find and interpret the interquartile range of the data. Wait, interquartile range. The interquartile range is the range between the quartiles. Well, we see the quartiles here. They're 19 and 22. We call the interquartile range the what? The IQR. And what's it equal to? It's equal to Q3 minus Q1. Quartile 3 minus quartile 1. Well, what's quartile 3? 22. This is the median. So quartile 3 is 22. Quartile 1 is 19. So that's 22 minus 19, which is equal to 3. Does that make sense? How many values are there between the first and third quartile? 1, 2, 3. Now let's interpret what that means. What percentage of the data is here? In between the quartiles, what percentage is here? Well, remember, the quartiles are 3 cuts. They split our data into 4 sections. Each one of those sections represents where 25% of the data are. So the box contains what percentage of the data? 50%. So that means 50% of our data is spread between 3 values. And I could have answered that a lot better now that I'm thinking about it. Couldn't I said the middle, I'm outside the lines. Oh, hey, to live outside the law, you got to be honest. The middle 50% of our data is spread between 3 values. And really, I don't know, couldn't we say the body mass index, the 50%, the middle 50% of 6th graders have a body mass index spread about just 3 values. Yeah, I could have done a lot better with this, but so be it. I've got like 15 other videos to record today. Hopefully you all understand it. And of course, if you have any questions, you can always just ask me. Okay, let's go to the last example. Try to blow through this. You've got it. How do I compare box and whisker plots from different data sets? Wow, look at that. That's going to be crazy, man. The double box and whiskers plot, double, as if it wasn't enough trouble just having one, represents the prices of snowboards at 2 stores. I feel like snowboarding right now. Okay, store A. So, well, I should say store A and store B. Okay, and then look, we have our prices down here. Okay, A, identify the shape of each distribution. Well, let's look at store A. What does that look like to you? Could we draw a line of symmetry down the middle and it's roughly symmetrical? I'd say, yeah. So store A is symmetric. What about store B? Well, store B, it'd be like climbing the ladder and sliding down to the right. See how most of the data is spread out to the right here? So store B is skewed right. Okay, now, next question. It says, which store's prices are more spread out? Explain. How can we determine how spread out a data set is? There are 2 ways. We can use, that's variation, right? We can use the range or the IQR. We could also use the MAD, but we can't actually build the data sets from what we have because we don't know what those 25% of the data, for instance, that are here between the first quartile and the median, we don't know what the values were. We just know 25% of the data is here. So we can use the range or we can use the interquartile range. Well, we can just look at it. I mean, which one is more spread out? Hopefully you see store B. Store B is spread over more values. Store B's, I'm going to actually use the prices are spread over more values. In other words, store B has greater variation. All right, everybody, that's the end for 10.4. I hope you kind of enjoyed it. It's been a long one, but you've done a great job. I'll see you later.